So over the years, we've talked about change sides, change signs, do the same to both sides, all of those sort of things when we're solving a linear equation. What makes an equation linear? What makes an equation an equation? How do you define an equation? Yeah, it's got an equal sign in it. It's really easy. If it's got an equal sign in it, you're expected to solve something usually. All right? If it doesn't have an equal sign in algebra, the likelihood is you're being expected to simplify it or do something like that with it. So, equal sign, solving. Same thing, if you're doing the same thing to both sides, it means if you've got x plus 7 equals 9, then that plus 7 we have to get rid of. We take it away from both sides. So if we take it away from both sides to get rid of plus 7, we have to minus 7. And we use that opposite relationship between our operations. All right? So we know that our opposite for plus is minus, our opposite for minus is therefore plus. Times is divide, divide is times. Right? That's pretty easy. Everybody knows that stuff. We've been learning it since year 9. So when we got to fractions, everybody got a bit confused about it. There are two sorts of fraction ways of solving. The first one, I'm going to call it a method, is to use a common denominator. This usually means that we have, so that equation went like this. Tell me again. E.g. x plus 4 over 3 plus minus x over 4 equals 18. Okay. So we're looking for that common denominator and we've worked out that it's 3 times 4 is 12. That's the denominator we need. 3 times 4, so far, so good. Right, now we need to work out how to get 12. So, to get 12 on the bottom here, we've got to multiply by, right, now we're getting somewhere. To get 12 on the bottom here, we've got to multiply by both top and bottom to enable them not to change, right? And to get 12 on the bottom here, we're multiplying the top and the bottom by 12, all right? So once we've done that, on the bottom here, we've got 12, 12, and 12. Because they are all the same, every single term, so if we had 10 terms, they'd all have to be the same, we can now forget about the bottom and only look at the top. So we've got 4 of these minus 3 of these equals 18 times 12. So we've got 4x plus 16 minus 3x equals 180, 196. Is that right? 216. Yes? My calculator in my head, not working last period. 4x minus 3x is x. 216 minus is 200, and we've finished. All right, so that method is called using a common denominator, and it applies when we've got more than 2 terms. We need to figure out what so it can have 3 terms. All right, and it can be not just numbers, it could be letters. Oh, I don't want to do this.
Use adding an x. Yeah. Yeah.
Right. So in this case, our common denominator is 3x. So to put this one over 3x, we've got to multiply by 3, this one by x, and what do we get? We get 15 minus x equals 5. They're now all 3x. So we get, remember that you can go this way. I'm going to do that. So I'm going to get 15 minus 5 equals positive x. X is 10. All right? So looking for whatever that common denominator is. The other method for solving these problems is used generally when we have just two terms. So we might have something like that. It doesn't have to be either side of an equal sign. We can move one over to be the other side, but it will only have two of them. And it's called cross multiplying. It actually is the same thing, but because we've got only two terms, we can cross multiply this by this and this by this. We are actually doing that as well, but then they're the same and they drop off, so we don't have to write the denominator. That times that will mean that we have the same denominator for the whole thing, so we don't have to go through that step. So this will give us 3x minus 1 equals 2 of these, which gives us 9x minus 3 is equal to 2x plus 2. Take the 2 over here. 9x minus 2x is 7x. No, write it. 9x minus 2x is 7x. And this 2 is here first, so it stays in front. The 3 gets added behind. Doesn't make any difference when it's adding. Makes a huge amount of difference when it's minusing. So if you're moving something to a side, it goes back to the back of the line. That equals 5. So our answer is... Now, this is the part that everybody gets wrong, and I've noticed in your homework you've been getting it wrong too. Good. 5 was there, it stays on top. 7 came over here, it goes to the bottom. All right? It's the one that we're dividing by the 7. Last year I made my class, because they were so bad at it, write it like this. Divided by 7... 7x divided by 7 equals 5 divided by 7 to make sure that they put the right number on the bottom. So if you can't remember which one goes around, the number with the 7 is divided by 7 because we want x by itself. The other one needs to be on the bottom. All right, so cross multiplying looks a lot easier because we don't have to get rid of that common denominator.